Morning, everyone. So, today's topic is the second module of renewable energy systems, that is the energy from oceans. So, here you can see the module like this. In the first part of the module, it is dealing with the ocean thermal energy conversion or TEC and the principal methods and different criteria for that. And in the second part of the same module, that is the module number 2, we are dealing with tidal energy and its details. So the modules 2 is divided into two parts, both the energy from ocean itself, one from the thermal conversion and the other one from the tidal energy. So let's see the first module now. The first part of the second module now. So you know that ocean covers around 71% of Earth's surface. That is major part of the Earth is covered by oceans. So we call our planet as a blue planet and all that you all know. Here, they receive, store, and dissipate energy through various physical processes. So the ocean receives energy so that it gets heated, and that thermal energy we can use. It gets stored and dissipate in different forms. And also all the living organisms that's inside the ocean also receiving solar energy so that they can live. So it is using solar energy, the ocean, as well as the living organisms inside the ocean breathe and do different activities. So here recoverable energy in oceans exists mainly in the form of waves, tides and temperature difference. So in our module what we are focusing on is that how we can produce electrical energy or electricity from using this stored energy that is available in the ocean. So we can use waves for that, we can use tides for that, and also we use the temperature differences that is available, that is from the surface to the deep layers. There will be temperature difference as it is collecting, the surface will be a little hotter than the deeper inside. So that also we are using. So with by using all these means, that is waves, tides and temperature differences, so we are recovering the energy stored in the ocean, that is we are producing or we are using this energy that is stored in the ocean, and we are producing a new form of electrical energy. Tides and waves produce mechanical energy, whereas temperature differences produce thermal energy. So from the sentences it's very clear. From tides and waves, that is it's moving, and with that movement we are producing the mechanical energy, and from that mechanical energy we are moving the turbines, and from that we can produce the electrical energy. That is one means. And the other means is by using that is a temperature difference, or the thermal energy part. So we will look into detail in the upcoming slides. And tidal energy technology is relatively more developed compared to the other two, which are still undergoing evaluation and initial development stages. So in current scenario, we are more dependent on tidal energy than the other two. Now, coming to the first one, that's ocean thermal energy conversion. We call it as OTEC. So we'll look into the introduction part first. The oceans and seas, which cover about 70% of the earth, are constantly receiving solar radiation and act as the largest natural solar collector. So, as you all know, 71% of the earth is ocean. So, it is collecting whatever solar energy available, it is falling onto the ocean, they are collecting. So, it is the largest natural solar collector. An ocean as a collector has an enormous storage capacity. And OTEC, that is Ocean Thermal Energy Conversion Techniques, converts the thermal energy available due to the temperature difference between the warm surface water and the cold deep water into electrical energy. So how we are producing, that is thermal energy, that is by the temperature difference that is available at the top surface compared to the deep inside. So deeper inside it will be very cold water, and on the surface it will be hot water. So this temperature difference, we are making the use of the thermal energy and we are producing electricity. An OTEC plant can cope operate in remote islands and seashore continuously. So the main application is in islands where we won't be able to transmit power, electrical energy from the shore. That is from the land. It is very difficult to reach electricity towards islands, which is very inside of this ocean. So in that case, we can use OTEC as an energy resource. And also in seashore, another method we can use like seashore method or offshore method. We will see that later. It is very low grade solar energy, so efficiency of the energy recovery is quite low. So as you all know, collecting solar energy and using that solar energy, we need to convert the temperature difference, which will be very low, around 20-25 degrees Celsius. So with that, converting that into electrical energy means the efficiency will be very low. So since the ocean thermal energy is dispersed over a large ocean surface area, it has a big potential. Compared to the other sources available, the ocean has a big potential, but the problem is its efficiency. According to MNRE, the overall potential of ocean energy in the country may be in the excess of 50,000 megawatt. There is an enormous opportunity to tap these renewable sources of energy. So even though we have large area, we are not using it right now. Hopefully we can use it as the technology advances. We will be able to use it very soon. So this is a potential sites of OTEC development that is under constructions, and you can see the temperature variations that's mentioned here, less than 18 degree, 18 to 20, 20 to 22. So we need at least 20 degree above, 20 degree difference from the colder inside, deep inside water. So then only we can produce the amount of electrical energy that we need. So this is the potential sites for OTEC development. And this is also another picture. You can see the marker operational construction phase planned and proposed. In red it is showing operational phases, and in green that is construction phases, and here planned and proposed. The yellow region, all the yellow regions, it is showing the planned regions, that is planning, and we are proposing new sites soon. That is also marked in the figure. So what is the principle of OTEC system? Now we can get into bit more detail. Solar heat energy is absorbed by the ocean water. Solar heat energy is absorbed by ocean water, as you all know. Temperature differences of about 20 degrees Celsius between the warm surface of water of the sea and the cold deep water. So the first criteria we can say it is around about 20 degrees Celsius. The temperature difference should be between to be around about 20 degrees Celsius between the warm surface water of the sea and the cold deep water. It can be explained by Lambert's law of absorption. That is, each water layer of identical thickness absorbs an equal fraction of light that passes through it. So once it hits the surface, it will be strong enough. But as it goes inside, it will be the temperature will be going down. So in the above surface, it will be around 20 degrees Celsius. Sorry, the temperature difference between the open surface, that is the surface that is directly facing the sun, and the deeper inside should be around 20 degrees Celsius. Then only we will be able to maintain the electrical energy that we needed. And intensity of heat decreases with increase in water depth. So as the radiation goes inside the water, the intensity also reduces, so that the thermal content in the radiation also reduces. So this can be explained by the Lambert's law of absorption, that is, each water layer of identical thickness absorbs an equal fraction of light that passes through it. ocean thermal energy conversion principle of OTEC system that is continuing here. So here, due to large heat transfer at the ocean surface water, the highest temperature is attained just below the top surface. The difference in temperature between the surface and the deeper parts of the ocean is utilized to generate electrical energy. So this is the main principle, that is the difference in temperature between the surface and the deeper parts of the ocean is utilized to generate electrical energy. So in the graph also you can see that at the surface it will be around, that is 0 meter. In meters it is showing, and in 0 meters, it is around 24 to 28 degrees Celsius. As it goes down it is decreasing, and it is decreasing as it goes deeper inside. So what is next? The basic process of OTEC is to bring the warm surface water and the cold water from the certain depth of sea through pipes so as to act as a heat source and heat sink for operating a heat engine. So same as the conventional thermal plants. That is, you can see here, it will form the same system as that of the conventional thermal power station with nil fuel consumption. So here we need a heat source, heat sink, and it should act like a heat engine so that we can produce the electrical energy at the generator side. The hot water for producing steam and cold water for cooling and condensing purposes. So same as like in a conventional thermal power station, we will be producing steam, and with that steam we will be rotating the turbines which will be connected to the generator, and there we will be producing electrical energy. But the problem here is the temperature that is available is very low. But the advantage here is that we don't need to combust anything. So there is no pollution that will be occurring in a thermal power station. So ocean thermal energy conversion, which is abbreviated as OTEC, is the main part that is dealing with the energy from the ocean. So here we can divide the methods according to the method that we are using in OTEC. We can divide it broadly divided into three categories. That is, first one is open cycle, which is also known as closed cycle. Second one is the closed cycle, which is also known as the Anderson cycle. And third one is hybrid cycle. Coming to the first one, that is the first method of OTEC power generation, that is the open cycle, or which is also known as closed cycle, open cycle or closed cycle. So what is happening is that simple like in control systems we call it as open systems, right? So here also there is no closed path or closed circuits available. So how it is happening? So it's from warm water from the ocean surface is flash evaporated under partial vacuum. Low pressure steam obtained is separated and passed through turbine to extract energy. The exhaust of turbine is condensed in direct contact condenser. The same thing which is happening here is there you can see that is the warm water here that is available at the surface and cold water at the deeper inside the ocean depths. Okay, so this difference in temperature, that is around 20 degrees Celsius or more, we can use it for producing steam. So what's happening here is that, one second. So here from the warm water it is going to the deaerator, which is we need to collect the steam from this one, so that it is going to the deaerator, and from that it is to the evaporator. So here it will be making to vapors. Okay, this low pressure steam will be going to the turbine, which is coupled to the generator, and there will be electricity producing here. So once again, from warm water which will be traveling here, and here the aerator, that is non-condensable gases and all those which is not necessary for us, which will be exited, and only the usable thing will be going to the evaporator. There will be a flash evaporator so that it can be vaporized. So this steam, the steam produced from the evaporator will be going to the turbine, and using this thermal energy, that is, the turbine will be rotated, and which will be coupled to the generator here. This is a generator available, and from that electricity will be produced. Once this the steam output from the turbine, it will be going to the condenser, and this condenser will be maintained from this cold water, that is the cold water from the deep inside the ocean will be used to condensate the steam from the turbine, so that it can be liquefy, and it can be redirected to the ocean again. So what happening here is, I'll explain once again. One second. Okay, so from warm water we starts. From warm water it will be going to the deaerator. The gases will be going outside, only the water will be coming inside. So this water will be changes into the vapor, and which is also low pressure steam. We can call it as low pressure steam, and this low pressure steam will be given to the turbine, which can be rotated, and which will be coupled to the generator, so that we can produce the electrical energy outside. And once the steam output will be steam is output, this output is connected to the condenser part. Here how it is condensed, the steam from turbine will be directed to the condenser, and the cold water from the deeper inside, colder water from the ocean, that is from the deeper side, will be given to the condenser, so that it can condense the upcoming steam. And this water, which is the condensed water, that is a liquid form, will be again put back to the water, that is the ocean again. So this is an open system. How it is an open system? Here there is the fluid or the water is not repeatedly using. Once it is taken from here, and it is going to the again to the ocean only. It is not reusing. There is no the reusing part happening here. So it is called as open cycle or closed cycle. So hope you are clear with that. And so warm water from the ocean surface is flash evaporated under partial vacuum. So that's happening here. And low pressure steam obtained is separated and passed through the turbine. Low pressure steam, you can see here, it is passed through the turbine, and then the exhaust of turbine is condensed. This is exhaust of turbine, which is condensed in direct contact of the condenser, and this is direct contact, which is given back to the. So hope the open cycle process is clear. So please draw it neatly and explain it properly. So the cold water drawn from the depth of about 1000 meter is used as cooling water in direct contact condenser. So in this condenser we are using around 1000 meter down from the water, from the 1000 meter down depths of the ocean, and it is used as a cooling water in direct condenser. The resulting mixture of used cooling water and condensate is disposed into the sea. So whatever that is happening inside, that is, it will be condensing, and the condensate as well as the cooling water which is taken from here, both will be deposited or disposed into the sea, and this is not again used by the system. Okay, so this is the whole process. That is why it is known as an open cycle system or closed cycle system. So once it is taken from here, the water is not at all reusing. It is going back to the river. Sorry, not to the river, it is to the ocean. So the condensate need not be returned to the evaporator, thus the name open cycle. So here, open cycle. Why we call it as an open cycle? Because condensate need not be returned to the evaporator, thus the name open cycle. So hope it's very clear.